What's up? Welcome back to another very exciting tutorial. Today we take a look into the new particle system within c4d. I will show you a cool technique for a product reveal. I also used this technique for my last project where I did a reveal of the new Canon prime lens.
Canon.
So without further ado, let's get started. Okay, for this tutorial we are going to look into the asset browser and take a package, in this case the muesli package, and the next step is to scale up the object itself because I found out that when you're working with simulations like particles, fire and smoke, the simulation itself is working better when the object has a certain size. In this case I use the cube as my template and scale up the project, scale up the object itself, and the next step is to look into the density of the object itself. So we have a density of subdivision of 2, so let's crank it up to 3, and now we are ready to rock and roll, and we are ready to step 2 for the setup for the lighting. So for my typical light setup, I create a light null object, and then I create 3 area lights, the top light, the key light and the fill light. And each of the light setup has a target tag on it, and I point the target tag on the light null object itself. So it is a typical 3-point lighting with a top light, the key light and the fill light. And the big advantage of this method is that I can change the light itself and also the position, the angle, without losing the focus on the object itself. So I always build my rigs and always build my commercials I'm doing with the customer like in this way. And it's a good starting point, I think, to have a 3-point lighting with this setup. Okay, now we are ready with the light setup. Let's create a camera. I usually prefer a camera with a focal length of about 50 millimeters. And let's play around with the camera, with the angle view, and in this tutorial I created a special layout that we can see the redshift render view, the material view, and the top, right, left, and the perspective view. Let's fire up the redshift renderer, and we immediately see that our fill light is way too intense. So we lower down the intensity from 100 to 10, and then we see the result is not so bad. We can then manipulate the key light and the fill light, its position and angle, and then we need a backdrop. And in this case I go into the asset browser again and search for the backdrop, backdrop studio backdrop, and I take it into my scene. And it's a cool object where you can manipulate many different properties, the height, the length and the width of the backdrop itself. And yeah, it's a very cool thing to have a nice backdrop. Because we are doing a commercial for mobile and for Instagram, we have to change our render settings, the aspect ratio, from a 16:9 to a 9:16 aspect ratio. And then we can manipulate the backdrop and the lights again a little bit for our pleasing. And I guess we are right now ready to our next step, the big step, the particle simulations. So let's start with the particle simulations. Before we dive into the particle system and the particle simulations, it's very important to do a little bit of housekeeping. It gives us a much more overview later on. And first of all, we create a null, and into this null we put in all the lights and the light null itself, and we can then disable the light setup, and we are not disturbed from this object on our screen. The second important step, I go into the view settings, and the save frame, I reduce the opacity, and now we are ready for the particle simulations. Because we are using different vertex color mappings and polygon selections and many modifiers to build up the whole simulation, it is not very easy to recreate the project quickly. So you have the possibility to download the whole project file with different lighting setups and camera animations for just $5, and you will find the download link in the description below. Okay, we then integrate the mesh emitter, and in the geometry property of the mesh emitter, we integrate the muesli snackback object. We crank up the rate of 5,000 particles per second, and in the property of the speed, we lower down the speed of 0, because we would like to manipulate the speed, the direction, and all things from the particles itself with the built-in modifiers and not with the speed itself. So let's test the simulation, the particle simulation. It's working. We are going into the group, particle group, and increase the dot size so that I can see a little bit more from 1 to 3, and it's working. Perfect. But we want a different particle simulation, a different particle emission. We don't want to emit all particles at once, but rather from a bottom to top. Later on, we play the simulation in reverse, and the snackback builds up as planned. But how can we do this? Well, we need a way to mask the backpack from the bottom to top, and we can do this with a vertex map. We can do this with a vertex map, and in the vertex map, we take a box field, and we change the size from the box field to 10 by 1 by 10, so it's a small size in the Y direction, and we can then simulate the box field from bottom to top. Let's do a short animation. Let's record the active objects, in this case the box field, from bottom to top. Okay. We have to zoom in and be careful that we really catch up the whole object. Okay, another point. And then we are going into the dope sheet, and we make a linear animation. Let's test it, and perfect, as we planned. So let's do a little bit of housekeeping again. Housekeeping, very important. Because later on we need another vertex map again, so we will rename this to vertex map emission particles. And unfortunately we can't use this for the restriction, because the restriction from the mesh emitter needs the polygon selection, so we have to convert it. We need another tag. This time we need the polygon selection tag. And in the polygon selection tag, we use the transfer property. And within the transfer property of the fields, we delete the freeze frame and we include the vertex map. And now it's converted. That means the vertex map is converted into the polygon selection tag. A little bit of housekeeping. We rename this to polygon selection emission particles, and we can then fill in this to the restriction of the mesh emitter. And now we see the perfect result. It only emits particles from the selected polygons, from the selected vertex. And now we can build up the simulation. Because we want to emit the particles from bottom to top, we need a wind emitter. And let's test the wind emitter. So we now see that the particles are emitting from bottom to top, but the wind emitter is not correct on the correct angle. We have to rotate it 90 degrees so that the wind is blowing up the particles from bottom to top. And yes, we see that the wind emitter is working. We changed the wind speed from 5 to 100. Now let's give it a little bit more wind. Perfect. It's working. So the next modifier we are integrating into our simulation is the turbulence modifier. Turbulence modifier is one of the most important modifier for particle simulations, I guess. And let's see, we are putting it into the particle group under the wind modifier. We are changing the strengths from 5 to 6 and also the scale. Let's see, about 12%. And let's give it a try. And we see immediately that it's changing a lot. The next modifier we are integrating in our particle simulation is the attract modifier, because we would like to attract all emitted particles to one single point. And I put it under the turbulence modifier, give it the strength about 50 and place it about 650 centimeters above our object. And it's very important to mention that all modifiers are processed within the particles groups from top to bottom. We can now see that the attract modifier is working instantly, a little bit too much, but there is a very cool modifier. It's the friction modifier. I use it on, I think, every particle simulation I do, with the strengths about 5 to 15. So in this case, we will need a 12 strengths. And it's a modifier which dampens the simulation in a very good manner from my point of view. So I use it a lot. So we can lower the size from the particle group to 1 again. And let's crank up the particle emission from 5,000 to 10,000. Give it a try. Yes, working good. Okay, but from my personal feeling, I would like to give it a little bit of a spin, of a rotation. So we integrate the rotation modifier. The rotation modifier between the turbulence and the attractor modifier. And we increase the angle speed to 60. And let's give it a try. So, and it's not the right thing. We have to rotate the rotation modifier, the axis from to 90 degrees to point upwards. And now it's working with the perfect rotation. I like that. Perfect. So let's test it again. So the simulation is working. Let's concentrate about the rendering stuff, rendering particles. We fire up the redshift renderer and we see we have green particles, and that's not what we want. We want to have the particles in the same color as the package itself. So we have to color remap the whole thing. But first things first, let's render the particles with the particle tag, with the redshift render tag on the particle group. And let's create the render tag. the redshift object tag. And in the object tag, we have the particles, and we changing it to more to the optical spheres. And there we have the possibility to change the size. So in the object tag, from the redshift object tag, we can change the size, whatever value we would like to have. And let's concentrate on the color mapping right now. First of all, let's increase the rate from 6,000 to 100,000. And let's see how it looks like. Perfect. So let's render this. And it looks cool. Okay, I think it's cool. It's very promising. Yeah, it's very promising. And yeah, let's concentrate about the color mapping. That's the next big thing. The solution in this case is to have a standard material where the packaging, the JPEG image, is in the color channel, but as a standard material, not a redshift material. This is important. Then we assign it to the color mapper. In the particle color mapper modifier, we switch to a field source and add a shader field. In the shader field, we then change the channel to the color and assign the material tag to the standard material. It sounds quite complicated at first, but once you understand the trick, it's a great technique. So this is the picture, this is the JPEG, and we locate the image in the asset browser, and there we find the necessary picture, and we open the standard material, and in the standard material we put in the source of the JPEG, and then we have a standard material with exact the same JPEG as the redshift material, but as a standard material. This is necessary for the color mapper. We then assign this standard material to the color mapper, and in the shader field we change it to the color and include the material tag in the material tag. And now the color mapper has its full function. And when we restart the simulation, we can then see that the particles itself are not green anymore. They are exact the same color info, has the same color information as the whole package, as the JPEG. Yeah, that's it. If you like this tutorial, then please give me a thumbs up and leave a comment. And please subscribe to my channel. I would be very happy to stay in contact with you. And because the color mapper has the right color information, we can now add a redshift material. And within the redshift material, we can add a color user data and change the attribute name to the particle color, and assign the output to the color input of the standard redshift material. And this redshift material can be then added to the particle group itself. And now all informations are correct. All information has the same data, and we can render this with a complete redshift environment. So right now it's time to cache the whole simulation, to cache the particle group. Therefore, we save this on disk. In our folder, we create a new folder called cache, give it a name, and click on save. The complete caching mechanism is starting, and the whole simulation will be cached on disk. this is absolutely necessary, because on the beginning of this tutorial I said that we are playing the whole simulation in reverse. That means that we have to have a possibility where we can reverse the complete simulation, and this is only possible if the complete simulation is cached. I will show you this in some seconds. So it is caching the process. So the cache is finished, and now it's much more quicker. We can wrap through the timeline. And now it comes the fun part. We can now change the time remapping within the cache object, and now it's playing in reverse. That's exactly what we want. Perfect. Let's give the render a quick try, and we will see the outcoming on the Redshift renderer. Looks very promising. Perfect. I love this. And yeah, we have to build up the next stage. It's the third one. Now we need to do something very important to achieve the wow effect. We need to build the material from top to bottom at the speed of the particle simulation itself. We do this, as in the beginning of the tutorial, using a vertex map, but this time in reverse. We define a vertex map and a box field, which this time runs from the top to bottom, exactly in sync with the particle simulation. We choose from the other tag the vertex map and give it a name. Let's say vertex package. Let's try the vertex map whole package. Then we use the transfer, delete the freeze frame, and include the box field, resize it, and make the complete simulation again as in the beginning of the tutorial, but in reverse, as I said. We go to frame 100, and there we make a record of this active object. We record the position. We go to frame 192, and now we see we have to resize the box, because we want to integrate the whole package from top to bottom. So we have to increase the size. Let's do it again. And maybe we remap this, the inner offset to about 96% maybe. Let's try 90%. No, it's not so good. Let's try 94. It's better. The important thing is that you are very precise in this stage. Otherwise, the wow effect is not so good as it should be. Okay, let's try it again on frame number 100, and we make a keyframe. We go to frame 189. Let's see. Okay, a little bit up, and yeah, I guess we Yep. Okay, that seems promising. Let's make a keyframe and should good to go. So the last thing we have to do is to tell Redshift that Redshift should only render the material which is marked within the vertex color, within the vertex map. So we have to integrate on the material vertex attribute, and in this attribute we integrate the vertex map into the attribute name and assign the whole vertex attribute to the opacity channel. And when you now render this new material, then you have the absolute wow effect. So this is the particle simulation with the vertex map and build up the whole packaging. Let's see. Give it some tries on different frames. Yeah. So maybe we have to fine-tune the box itself. We have to fine-tune the light, of course. We have to fine-tune the material, and yeah, as you can see, it is very important that you be absolutely precise within the box field, within the vertex attribute, and to be in sync with the particle simulation itself. Otherwise, it doesn't have this this wow effect. So let's do a little bit adaptation. We try the inner offset of 100. No, it's not good. We try it on 96, and we go into the box field, into the keyframes of the box field, and let's change the in the dope sheet the fields, the animation itself, a little bit precise, to be a little bit more precise. So, for instance, I changed it to a linear simulation, and this should be much better. Okie dokie, it seems perfect. Yup. And so let's try a different angle. Let's rotate the camera. And so we build up different stages or different camera views and build up the whole animation, the whole commercial from the packaging. Yeah, this is it. I guess it's promising. Perfect. It's a lot of fun playing with the new particle system in Cinema 4D. And the possibilities are endless, especially if you combine the particle simulation with other simulations, like cloth simulation, fire and smoke. Thanks for watching, and again, if you like this tutorial, then please give me a thumbs up, leave a comment, and please subscribe to my channel. I would be very happy to stay in contact with you, and we will see you next time. Bye.